Let's hit these. 5, 5. Have you guys done midpoint and distance formula stuff before? I don't think so. Okay, so the midpoint and distance formulas. I like both of these, partially because they make sense. I always was a big fan of, if I am given a formula or given an equation that's solved for one variable, if I can look at it and understand why it works, I always liked those. And so first one we're going to do is Roman numeral 1 is going to be the midpoint formula. And what it's really trying to say is, if we have a line segment, or if you have 2 points that are connected by a straight line, we're trying to find out what's going to be the middle of those two. And I'm just going to start out by I'm going to leave a little space here to actually write the equation. So it's going to be fairly large. I'd leave at least a couple rows, but I'm going to kind of work over on the right-hand side some. And say I have a graph. And on my graph, I'm going to throw a couple points on my graph. And so maybe there and there. And connect them with a line. But have the line end at both of those. So technically it's a line segment. But the point of what we're trying to do is we're trying to find what's the midpoint. What's going to be that very middle spot on the line. Fair enough? Yeah. And if we're going to get that, well, we could take our original. Maybe let's switch to orange. If I take this, this could be, well, this is going to be one of my x values. Agreed? The x value, that point on the left. You could, if you wanted to, call it x1. Don't let the 1 confuse you. It's just saying this is my first x value. This is my second x value. So maybe call that x2. That midpoint, that point right in the middle, if I take and drop that thing straight down, if my drawing's any good, what do you notice about my x value of my midpoint? It's in the middle, right? So if I were to have numbers, maybe just make up that this here is 2, so then, so maybe this here is like a 6. My midpoint would have to be 4. Do you agree that it's going to be right in the middle of the others? So in other words, if I want to find my x value, so if I have a midpoint, so this is supposed to be like a big ordered pair. My x value is just going to be the average of 2 and 6, right? So it's going to be right in the middle of those two x values. So to find the right in the middle, we just do the average. So I take and I do my x1 plus my x2. Add the two of them together, divide by 2, and I get the x value of my midpoint. Yes? Any guesses at what's going to happen over for my y value of the midpoint? It'll be y1 plus y2 divided by 2. Because if I want to find out what's the y value of my point here, well, if I take, here's my first y value, y1, here's my second y value, y2, the y value of my midpoint, if I drew it right, should end up being like right in the middle. And so if I take my first y value, my second y value, average them, add them together, divide by 2, get my new one. Good? So that's going to be one type of question you're going to get from this midpoint. I could take and actually throw some points in there. Would it be good to go through one? I guess maybe, yeah, let's quick do one. If I say, take my problem here. I'm going to get rid of my dashed lines. And you could quick redraw it if you wanted to, if you want to try to make yours look honest, if you put in the dashed lines. But if I have my lower point, I'm going to say is 2, 3. And my upper point, I already said was 6. Maybe, I don't know, 9? 6, 9. If I wanted to find the midpoint of those two, if you struggle with this, it wouldn't be bad to go through and label out your x1, y1, x2, y2. You could do that. But so you could say x1, comma y1, and then you could kind of line things up if you wanted to. But really, it doesn't matter which one's my first x value, which one's my second, because we're just adding them. But so if I wanted that midpoint, just say, well, one x value is 2, the other x value is 6. You take those and divide by 2. So 8 divided by 2 is 4. My y values are 3 and 9, so if I do 3 plus 9, I get 12. Divided by 2 gives me 6. So my midpoint's 4, 6. The place that gets a little bit uglier is if they give you an example where they give you the midpoint in one end, and then they want you to find the other endpoint. So I figured it'd be worth doing an example like that, because those are a little bit beastly. So I'm going to say finding an endpoint. I hesitate a little bit to do the nice drawing, because for me, I just would get it from the drawing. And if they don't give you a drawing, you could go and make a drawing, then you'd have to have graph paper. So it's good to be able to do it just like in your head as well. But say we have a problem, something like this, and I'm going to say they give us this endpoint is 1, 5. They tell us the midpoint is 3, 3. And now we're trying to find this lower, we're trying to find this x, y. Can anybody just look at the drawing and come up with what it's going to be? That's the part that I think is kind of fun. Well, why is it 5? From here to here you go over 2, right? So if that midpoint's right in the middle, you have to go over 2 more, so you're right, you get 5. And you get the same thing here that you went down 2 to get the midpoint. So if you're at 3, go down 2 more, you get 1. So if you can kind of hack through it that way in your head, go for it. It's probably nice to be able to come up with what's it going to be mathematically too, in case you're doing like screwy decimals, in case you don't have something that's kind of easy to draw on a graph. But how would we get that mathematically? Well, if we go back to our original equation, I guess you can't really call it an equation, but this part right here, that equals, maybe I could say like a x sub m, like the x value of my midpoint. I kind of convince you of that. So the other way to, let's just get rid of that then. I could say, all right, down here, I'm going to say the x value of my midpoint equals the average of the other two x values. So x sub m equals the average of the other two, x1 plus x2 divided by 2. And then you could take and just fill in your numbers. I know my midpoint x value is 3. I know my x1 is going to be that right there is going to be my 1. So I now have that equation. In other words, I'm trying to find the second x value, that number right there. So I need to fill in everything except for that. I put in my midpoint value, I put in my 1x value. And now I could go through and solve for my missing x, or you could say x sub 2 if you wanted to. But, all right, so first I multiply by 2 to get rid of that, and I have 6 equals 1 plus x. To get x by itself, I would subtract 1. So then my x sub 2, my second x value, has to be 5. Good? And you could do that same thing with the y values. You could say, well, my y value of my midpoint is going to be the average of the other two y values. So y1 plus y2 divided by 2. Plug in the numbers or smile and say, we're good enough, we're smart enough, and doggone it, people like us. Move on? Okay. Then, the distance formula. The next one is the distance formula. Distance formula, I'd say probably the toughest part for people first learning it is that it looks ugly. And I think a lot of people, they get intimidated by it. Don't be. I want to kind of show where it comes from again. And I'll do that over here on the right, and then I'll write out the actual thing. But say I have, now instead of finding the midpoint, if I have a line segment with a couple points there, we're trying to figure out, well, what's going to be the distance of that? What's going to be the length of that thing there? If I take my point right here and call this point x1 comma y1. And my upper point here, I'll call that my second x, so x sub 2, and my second y sub 2. Still with me? The distance formula is really just this. If I could take this and make it into a right triangle, you guys remember how to find the hypotenuse of a right triangle? If I label this A, that B, and that C, A squared plus B squared equals C squared, right? So I probably wouldn't write some of this stuff here that I'm going to put, but here's how it works. That if we're trying to find C squared, the distance there, so I wouldn't write this if I were you, that's going to be equal to A squared plus B squared. Still good? But I'm not trying to find C squared, I'm trying to find C. To get rid of a square, do you agree I could square root? Yes. And when I square root, what happens on the left side is the square root and the squared cancel, and I'm just left with C equals A squared plus B squared. Or square root of A squared plus B squared. Good? So that's what we're trying to do. Now to get this, if I want to figure out, well, what's my distance A? Well, if this is my first x value, and this is my second x value, what do I do to those two x values? So this is my x1, this is my x2. What do I do to those to find that distance between it, which we called side A? Add them, subtract them, multiply them, or divide them? Yeah, well think about it in terms of numbers. If this one's over 1 and this one's over 5, what's the distance between those two? 4. What do you do to 1 and 5 to get 4? Subtract them, right? Okay, so where I have this thing here, my A, that A is going to come from subtracting the x values. It's finding how much do we go side to side, agreed? With that, if I do 5 minus 1 here, I get 4. If I do 1 minus 5, I get a negative 4. Does it matter which order I do it in if I'm going to square those things next? No, because 4 squared is 16, negative 4 squared is 16. So the order doesn't matter. I'm going to copy it down the same as what the book did. Instead of that A squared, I'm going to say that's going to be my x2. Actually, I'm going to switch to red. I'm going to say x2 minus x1. That's A, right? The length horizontally. I subtracted my two x values, my 1 and my 5 in that case. So x2 minus x1 is my A. I need to square that to get my A squared. Plus, now B squared, B is my height over here on my triangle. B is going to be, the length of this side here. What do I do to my y values to get the length of that side? Subtract them. And you could go through and do the same thing, y1 and y2. But to get that B, it's just going to be y2 minus y1. Or you could say y1 minus y2 if you'd rather. But then we square it because it's B squared. And now we had square root down here, so I need to square root my thing up above. And all of that's going to give me side C. Yes? But if we're trying to find distance, it'd be dumb to have C be the variable for distance, so instead they write it as d, lowercase d for distance. So this here is the distance formula. So the distance formula really is just doing Pythagorean theorem problems. They write out the equation in a way that you don't need to solve. You can just put in your points and plug and chug like crazy. All right, let's do one example, and then we are done for today with notes. So example, if I were to say, all right, I have a point here that's 2, 3, and I'm going to go up to 8, 7. And the question's saying, find the distance of that line segment, or find the length of that line segment. I plan to, on the test, ask you to know both of these equations from memory. So in Algebra 2, when I did that, I'd always have some people that the night before, they're cramming. I would instead just do this here. When you do one of these questions, quick write out the formula. You're a lot more likely to get it right, and come the night before the test, you'll know it from memory. But I'd start out by doing this. It's just going to make it a whole lot easier as you're trying to learn the problems the first time. If you want to, you could label x1 and y1 x2 and y2. Don't have to. But now really it just becomes a plug and chug thing. It's not bad math-wise if you just label it all like that, because now x2 is 8, minus 2 is my x1. And maybe I'll throw my square root in there now. y2, well that was 7, minus y1 is 3. I need to square that. So I have 6 squared. 8 minus 2 is 6. 6 squared is 36. Plus 7 minus 3 is 4. 4 squared is 16. And then so that becomes square root of 52. Yes? And for now we're just going to be able to punch that in and say, okay, that's approximately equal to 7.21. Suppose if you wanted to give the exact answer, you could just leave it as square root of 52. But I take either of those. Square root of 52 is the exact answer, or 7.21.